Thanks for inviting me. This is not a very refined talk. You can understand that the eruption finished just a few weeks ago, and we still are wondering about the amount of data we collected. So we still had no time to take a detailed look at all the data, geophysical, geochemical, and petrological and volcanological that we collected during this 3 months eruption. And so I'm going to show you just some preliminary results, mostly about geophysics, and I would say mostly about seismology. Talking about all the data collected will require hours, and I have just 20 minutes, I guess. So just a few information about this eruption. This eruption was very astonishing and surprising for us because nobody would have expected an eruption of such a magnitude in Canary Islands. So under different aspects, this eruption was a record breaker. The area covered by the lava is the largest among the historical eruptions in La Palma. It covered more than 10 square kilometers. This is the hugest lava flow, among the hugest in the Canary Island. The previous one, the largest previous historical eruption, was just 4.5. Sometimes the lava flow rates reached peaks of more than 100 cubic meters per second. This sounds like Kilauea, so it was totally unexpected for Cumbre Vieja. Well, the amount, probably the most surprising aspect was the explosivity of this eruption, which was almost completely unexpected. And the character, the explosive character of some phases of the eruption led to the deposition of at least 20 million cubic meters of tephra, of distal tephra. And for this reason, this eruption exceeded the threshold of the volcanic explosivity index of 3. And this is, there are very few precedents in the Canaries of eruption with such a strong explosivity. And well, the eruption lasted more than 12 weeks, well, about 3 months. And this also is another record because the previous eruption in La Palma lasted only 3 weeks. The amount of sulfur dioxide emitted by this eruption and measured both by on-site, by Minidoa's service, and by satellite Sentinel topomy data was surprising. There were peaks of more than 70,000 tons per day, but usually the average during most of the eruption was above 10,000 tons per day, and this also was unexpected. This is one of the known eruptions which emitted the highest amount, the total amount of sulfur dioxide, but also of carbon dioxide. The eruption was a typical fissure eruption with many vents active simultaneously. Usually the vents were aligned along the main eruptive fracture, but in the last phase of the eruption, we observed the opening of orthogonal fractures with vents which sometimes were so strong to change completely the morphology of the previous volcanic crater. Well, we observed the formation of 3 different lava deltas. We recorded an immense amount of earthquakes. The automatic detection system detected more than 100,000 earthquakes in 3 months. We were able to, until now, to manually locate more than 11,000 of them. And many earthquakes had a magnitude strong enough to be felt, and about between 16 earthquakes at the magnitude exceeding the 4, and they were strongly felt on all the island with macroseismic intensities up to 5. Well, not only from a scientific point of view, this eruption was also a record breaker from considered impact the eruption had on the society and on the infrastructure of the island. Well, first of all, the eruption destroyed about 1,500 buildings. Buildings means houses, farms, and other factories and so on. So this eruption was really strongly damaging, and actually the eruptive vent opened not in a highly densely urbanized area, fortunately, but in an area in which was practically in the middle of a town. So this is why the eruption had such a powerful destructive impact. Well, the eruption forced the evacuation of 7,000 persons. Now many of them are going back to their houses, but many of them, about 3,000, have lost completely their home, and so that they will need to be reassigned to a different place. The eruption, the lava flow affected a lot of roads, and most of them affected an highway, LP2, which was one of the most important of the island. So the eruption affected strongly, very strongly, the traffic of the island. Well, the airport was required to be closed many times, at least 4 times, if I remember well, and even the airport of Tenerife, which is about 100 kilometers away from La Palma, was required to be closed a couple of times because of the ash cloud. And well, the area around the eruptive centers suffered for most of the eruption problems with the air quality, with threshold for SO2 and fine particles, which were exceeded almost every day, and this posed an unprecedented problem in managing this issue. This is probably the first time that an eruption has been studied so densely in terms of air quality, with a very dense monitoring network and with portable temporary stations and with portable sensors, which were used all along the duration of the eruption. And well, there were multi-other issues. That means, for instance, that the lava flow affected deposits of fertilizers, whose burning posed air quality issues which were not directly related with the eruption, of course, but they were a very serious issue. And well, the eruption is going to have long-term effects on the agriculture because of the huge amount of ash which affected the whole island. And the ash was specifically rich in fluorine, which has still to determine effects, long-term effects on the agriculture and on the farms of the island. Well, there is still a hazard for lahar. There is a lot of ash deposited on slopes, and well, even if this hazard recently has been evaluated better than during the eruption, it seems to be less worrying than we believed during the eruption. So because there were some tests realized with simulation of rain on actual slopes, and it seems that the remobilization of the pyroclastic deposits emitted by this eruption is less easy than expected. So this hazard is right now it's not so important. And well, definitely there were very relevant and there was an economic impact which still has to be determined completely, but right now it is estimated to be between 550 700 million euros only for the island of La Palma. And well, definitely this is probably the most damaging eruption in Europe after the 1944 Vesuvius eruption. Well, let's go back to science. Well, this is just a general overview of the Canary Island. Well, the Canarian archipelago is a typical hotspot volcanic archipelago with eastward movement of the lithosphere, which makes the westernmost island the youngest. And actually, La Palma and El Hierro, which erupted in 2011, are the most the island in which the most the outcrops are the youngest. In the western part of in the eastern part, sorry, of the archipelago in Fuerteventura, the oldest outcropping rocks have been dated more than 20 million years ago. And well, this is an overview of the island. The active part, the currently active part of the island, it's in pink. This is the Cumbre Vieja volcano. The northern part is Taburiente Caldera, which is no more active. And here there is a 3D plot of the historical lava flows. And well, the last one was located just beneath the San Juan eruption of 1949, and this, which is the oldest known historical eruption of La Palma Montaña Quemada. Well, this is a map of the evolution of the lava flow. Well, this is not the last one because at last this lava flow reached the sea at the end of November, more or less. But you can see that the evolution was very rapid, and what was expected to be a not so dangerous eruption because of the rapidly changing conditions at the eruptive vent with repeated collapse and the opening of new vents made that the eruption, the lava flows affected this part, the northern part, causing a lot of damages. So actually the blue lava flow, the blue and the purple here, were the lava flow which caused most of the damages. Well, this is the onset of the formation of the last lava delta with the formation of a hydromagmatic plume which was rich in chlorine, and this was also an issue because the pollution was not only from the volcanic plume rich in sulfur dioxide, but also from the marine plume, which was rich in chlorhydric acid. Well, this is more or less a 3D view of the last lava flow, and you can see how it affected well, not so densely urbanized. The highest urbanization were a few kilometers on the north, and fortunately the eruption was not able to reach this part of the island, but you can see how many buildings have been affected. Just to give you an idea, this is the previous eruption, well, one of the previous eruption, the 1949 San Juan eruption, which consisted of a lava flow which reached the sea, but you can see that the area occupied by the lava flow was much lower. Well, let's start talking about earthquakes. Well, this is the seismic network that we deployed on the island before and during the eruption. And well, by the way, apart from traditional seismic network, we had the opportunity to deploy middle of October what is known as the distributed acoustic sensing system, which basically is a laser system which made a submarine fiber optic cable connecting La Palma and Tenerife to act like a seismic network. So it was like having more than 5,000 virtual seismic sensors deployed along this cable here, up to a distance of about 50 kilometers away from the island. So this is probably the first eruption which has been monitored in real time using such a system, and we recorded terabytes of data which we are starting to analyze right now. Okay, so the eruption was not completely unexpected because some geophysical and geochemical precursors already started at least in 2017. In 2017, there was a first swarm of earthquakes beneath the island after nearly 40 years of silence after the last eruption in 1971. And in the following year, there were 9 different seismic swarms. I'm talking about very low magnitude seismic swarms with a maximum magnitude about around 2. They were not felt by people, just recorded by the seismic networks. And well, everything changes dramatically on September 10, 2021, when we started recording an intense seismicity at a very shallower depth. So most of the earthquakes in the years before the eruption were located around 20 kilometers depth. And on September 2021, earthquakes start to be located at 10 kilometers depth, so quite shallower. And well, this is the depth of the seismicity preceding the eruption, and later I will give you my interpretation of this seismicity. But let's talk about some geochemical precursors. Well, one of the most relevant geochemical indicators of magmatic arrest is the helium-3, helium-4 ratio, whose value indicates a possible magmatic recharge at depth. And actually, in August 2020, this value recorded at a thermal source on the island, measured at a thermal source of the island, reached the highest peak of the previous record, which started around in 1992. So it's a very long record, and this was the highest value of all the time series. So it was already indicating that in 2020 magma was moving at depth. Well, there was another peak already in 2013, which was the highest compared with the previous values, which probably was the first precursor at all of the incoming eruption. And well, this is the helium CO2 ratio measured from diffuse degassing on the island, and you can clearly see this amazing peak after the first swarm in 2017, October 2017. So this was another evidence that magma was moving at depth. Well, another peak was recorded during the eruption, but that's another story. And well, as I told you, in September, seismicity started almost suddenly on 11, but it went skyrocketing on September 12, with more than 400 events recorded each hour. So it was a very strong seismicity, with many earthquakes felt by the people, and with a westward and then upward migration of the seismicity until on September 19, the eruption started right above the last cluster of earthquakes. So the seismicity was marking very, very clearly the path of which magma followed, starting from 10 kilometers depth up to the surface. So under this point of view, the volcano was gentle because precursors were very clear, even if extremely rapid. In less than 1 week, we passed from weak earthquakes to an eruption. And well, this is a time depth plot of the earthquakes, and you can clearly see the ascending hypocenters, which accelerated just few hours before the actual eruption, which was in the afternoon of September 19. Well, here there are few earthquakes, shallow earthquakes, which seems to be detached from the main cluster. Well, right now the interpretation of such earthquakes is that they are not directly related to the movement of magma, but they are more or less related to the liberation of hydrothermal fluids, which triggered this shallow seismicity. And this seems to be confirmed by seismic interferometry, which shows a decrease in the average seismic velocities a few days before the eruption, in coincidence with the appearance of such weak shallow earthquakes. Well, this is a map of the observed velocity variation, and you can see that the most relevant decrease coincides with the region in which the earthquakes, the shallow earthquakes, were actually located. Well, this is the eruption started almost completely unexpected. It is true that in the morning there were strong earthquakes with magnitude exceeding 4 at very, very shallow depth. So everybody was alerted, but the eruption started almost silently. This is the first volcanic plume that we observed, and well, the eruption evolved quickly toward typical fissure eruption with at least 4 vents active simultaneously. And well, in the next months, we observed the formation of a huge volcanic building, which right now reach an elevation of about 200 meters above the previous topography, with a very complex geometry with different, very many interesting volcanotectonic features. And well, this is the volcanic tremor, which is one of the most relevant indicators of the intensity of the explosive activity. Well, you can see this is a zoom on the first hours of the eruption. And well, the volcanic tremor was not a true precursor of the eruption, because it started increasing just few minutes, 20 minutes more or less before the onset of the eruption. So it was not a reliable precursor. And there was a very striking episode on September 27, in which the eruption practically stopped for a few hours with just a weak gas emission, and then resumed again, but this time with a different and more effusive character. The first phase of the eruption probably was the most explosive at all, with very strong detonations and with a tall volcanic plume, which reached sometimes 7 kilometers elevation. There were some explosive episodes in October, and at the end of the eruption, if the eruption was the onset of the eruption was surprising, its termination was even more, because few hours before the eruption, the volcano stopped again, then resumed with a very intense explosive activity, reaching a peak on December 13 with an eruptive column of more than 8 kilometers. It was really incredible. And then suddenly, really suddenly, in few minutes, the eruption stopped completely. And right now, it is still, it finished without resuming any activity. Just right now, the only activity visible is just degassing from the whole volcanic edifice. And well, as I told you, this phase was interesting because marked the transition from a more explosive phase to I would say mixed explosive effusive phase. Well, it was effusive, but also with some explosivity peaks. Well, also the composition of the magma changed a little between this first phase and this second one. In the first, it was more tephritic, and in the second was mostly basanitic until the end of the eruption. Okay, well, this is the Syn-eruptive seismicity, which was surprising as well, because usually you expect the seismicity to decline once the eruption starts, but this is not the case of La Palma. Actually, a week after the onset of the eruption, seismicity started increasing progressively until reaching a peak in October, with a lot of strong earthquakes felt also in the nearby island. But the peculiarity of this seismicity was that it was located all the time in two separated clusters, one around 10 kilometers and another one around 25. And this was a persistent feature all along the eruption. And even right now, there are very, very few earthquakes in these days, which are located exactly on the same clusters. So the Syn-eruptive seismicity was surprising because of its intensity and because of its location, which was very peculiar. And later I will explain a possible interpretation of this pattern. Well, what...
Luca, we're nearing the end of the seminar. So
yes, I'm finishing. Yes. Well, just... we can pass this part, just technical details. Well, we obtained a preliminary velocity model of the volcano using the data collected during the eruption, and we were surprised to, well, not so surprised, we observed a very huge volume of more than 400 cubic kilometers of a volume with a high PVS ratio. This is not a magma chamber, of course. It will be a gigantic magma chamber. This is a zone filled with fluids. A part of this volume is magmatic, but not all, of course. But it is very, very clearly depicted by seismic tomography. And well, ground deformation, it's not so surprising. There was an inflation, a rapid inflation of the volcano in the week before the eruption, and then a slow deflation, which has been observed until November, more or less. Well, this is a technical detail. And well, what about the interpretation of what we observed? Well, we start from a conceptual model which has been developed by petrologists. Petrologists using fluid inclusions and other kind of petrological studies determined that most of the eruption of Cumbre Vieja are related to at least two magmatic reservoirs, one located in the upper mantle, which seems to be some kind of ephemeral magmatic reservoir, and a subcrustal reservoir located around 10 kilometers depth beneath the volcano. So if we compare this with the seismicity distribution, we see an excellent agreement. So it seems that the earthquakes, the two clusters of earthquakes located during the eruption coincides with the two infrared magmatic reservoirs. So what we think it was happening before the eruption was a long-term accumulation, a seismic silent accumulation of magma at depth. And then in 2017, we first observed a migration of the magma toward the subcrustal reservoir with the seismic swarm located around 20 kilometers depth. Then on September 2021, we observed the migration, the formation and the propagation of a dike connecting the subcrustal reservoir with the surface when the eruption started on September 19. And then later, what we observed was mostly a deflation, a readjustment of the two major magmatic reservoirs, with the seismicity located constantly along all the eruption at these two specific depths. Okay, so that's all for now. If you need more information, well, feel free to ask me, to contact me. Just to let you know that in our Twitter account, we published a lot of photos, movies, and other kind of information that may be useful for you. Okay, thanks.